So let's start some of these problems on midterm review practice number 4. We'll see how far we can get, and then if I have time, I'll continue with the part 2 video. So this is on wits. There's one that says blank, and you can print that out to get a page to do your work on, and then the other page should be an answer key. So let's get started, jump right in. Number 1 says factor completely. So remember, you want to look for a GCF first, and the other types of factoring are dots, and then we have trinomials that we need to work with, and last but not least, you might have a grouping factoring question. So I look at 2x squared y cubed minus 72y, and I see I can take out a 2, and I can take out a y, which leaves me with x squared y squared minus 36. Keep that 2y there. X squared y squared minus 36 is definitely dots. It's a difference of 2 squares. xy times xy, and 6 times 6. And now we're done. Number 2 says to solve for k. K is down here in the denominator. It's an equation. So once we have the same denominator on both sides, or once we simplify or cross multiply, we can do this in a variety of ways. Let's go and get a common denominator first. So I see I might need an LCD over here, and I have a k and a 2, so 2k. So on the 3 over k, I want to multiply by 2 over 2, which will give me 6 over 2k. And here I'm going to need 2k over 2k. And on the other side, k over k. Now that we have the same denominator on both sides, we can get rid of it as long as you have an equation. And that says, let's see, that we are left with 6 plus 2k equals k. I'm going to bring this k over so that I have a positive k here, and I'm going to subtract the 6 over. So k equals negative 6. Now anytime you solve something, you should check it. Make sure you did your work right. So we have a negative 6. I'm going to come back to the beginning here. Not a lot of room on this sheet. So 3 over negative 6 plus 1 equals 1/2. We're doing a quick check here. 3 over negative 6 is negative 1/2 plus 1 is 1/2. So I do get 1/2 equals 1/2. So it checks quite nicely. Great. Number 3. Solve for all values of x. And I can see here I have an absolute value equation. Absolute value, you want to remember those 2 bars. So on the left, 4x minus 1 equals 3. We're going to solve that. And on the right, 4x minus 1, no change there, equals negative 3. So we negate the other side. Adding 1 gives me 4x equals 4. Divide, and x equals 1. Adding 1 gives me 4x equals negative 2. Divide, and I have x equals negative 1/2. Now once again, I've just solved an equation, and I can certainly check my answers. If you've solved for x, you can check your answers. So I'm going to do real quick over here, just showing you good habits. Absolute value of 4 times 1 minus 1, hopefully that equals 3. I don't have a lot of room, so this is 4, take away 1. Is the absolute value of 3 equal to 3? Yes, 3 equals 3. So 1 checks quite nicely. And let's do negative 1/2. So we have, let's see here, the absolute value of 4 times negative 1/2 minus 1. Does it equal 3? 4 times negative 1/2 is negative 2 minus 1. In the bars equals 3. So in the bars, I have negative 3, and that is 3 when I take the absolute value. All right, so great. They both check. Number 4 is an exponents question. So you want to know all those exponent rules. Chapter 7. So I've got 5 to the x to the 3. Power to a power, I multiply. And I have that multiplied by 5 to the x plus 2. Now I have base. Base times base, we keep the base and we add the exponents. So I get 3x plus 2, which is 5 to the 4x plus 2. Going kind of fast here. Hopefully I won't make a mistake. We could check this as well. We didn't solve anything. But if you really wanted to, you could make up a number for x. Let's say pick 3. So you could put a 3 in there, put a 3 in there, work it out, and then you could put a 3 in here and make sure that they equal the same thing. So you could do a little calculator work and check that as well. Number 5 says to solve for x. Now this I see a radical and it's an equation. This one, checking is a must. You can get extraneous roots here, and these are the questions that a lot of kids make that last minute mistake. They forget to check. So let's add over this square root. I don't like it to be negative. And I'm going to bring the 2 over by subtracting. So this is going to end up looking like 4 equals the square root of x minus 2. Take a minute and do that if I confused you. I'm bringing this one over to the other side, and I'm subtracting 2 over. So I end up with 4 equals square root of x minus 2. Now that I have a square root, I'm going to square both sides, and end up with 16 equals x minus 2. Well, this looks nice. That's going to just be then, add 2 to both sides, 18 equals x. Okay, we've solved, we should check. Especially check these. 6 minus the square root of 18 minus 2. We're checking if it equals 2. 6 minus the square root of 16 is 6 minus 4, and that is 2. So we're good. Check works. We're going to keep our answer. All right. Number 6. Number 6 says, which of the following represents direct variation? Remember, that's a line through. Which represents indirect variation, also known as inverse variation. And inverse variation, remember, those come out graphically looking like this, and that occurs when you have the product of each of the values equaling a constant. So let's see what we have here. We can play with these a little bit. This one I could cross multiply if I wanted to, get 6y equals x, and then sure enough y equals x over 6. That's a line with a slope of a 6, so that one is direct variation. This one I can cross multiply. I get xy equals 6, so I can already tell xy equals 6. That product equals a constant. That's indirect variation. If you graph y equals 6 over x, you would see something that looks like that. Number 3 is a horizontal line through 6. So this one is neither. Because remember, to be direct variation, you need to go through the origin. And I guess this got moved. None of these was a choice, so that got moved. That's a little weird. Inverse, none of these. Oh, which of the following represents direct variation? Which, okay, whatever. There we go. Direct, indirect, and neither. Number 7. Simplify and express in terms of I. Okay. So we have a 3 times negative 49 square rooted is 7I minus 2 times 5I minus 3I. So remember, when we have a negative under a radical, the square root of negative 1 equals I. When we have a negative under a radical, we bring that I out right away. This is 21I minus 10I minus 3I. So 21I minus 10I is 11I minus 3I is 8I. If you're in A plus BI form on your calculator, or mode rather, you could probably put this whole thing in your calculator and it would give you this answer as well. So there's another nice way to check, just to be 100% sure. Number 8, express 3 over 2 plus radical 3 as an equivalent fraction with a rational denominator. So here we need to deal with the conjugate. The conjugate of A plus radical B is A minus radical B. Sometimes we're dealing with I as well. So I see my denominator is 2 plus the square root of 3. I need 2 minus the square root of 3, multiplying top and bottom. So on the top, 6 minus 3 radical 3. On the bottom, 4 minus 2 radical 3 plus 2 radical 3, those drop out. And then minus radical 3 times radical 3 is just 3. So that's 1 in the denominator, 6 minus 3 radical 3. Number 9, express the product, that means multiply, of 1 plus 3I and 2 plus 4I in simplest A plus BI form. Here we're going to have to remember that I squared is something special. So let's FOIL this. The firsts give us 2. The outers give us plus 4I. The inners give us plus 6I. And the lasts give us plus 12I squared. So we have 2 plus 10I plus, and now we need to remember that I squared is negative 1. I squared is negative 1, comes up frequently. So if I multiply 12 by negative 1, I actually end up with negative 12 there. And we can combine that with the 2 and get negative 10 plus 10I. Terrific. Remember, you're in charge here. Pause anytime you need to. Rewind if you need to. Walk away and come back if you need to. Number 10. For which ordered pair, x, y, is this fraction, 3 over y minus x, undefined? So undefined fractions happen when the denominator is 0. And we know the denominator being 0 is a bad thing. We don't want denominators to be 0. So here they're asking for the pair x, y that would make a 0 denominator. So basically, y take away x, I would need them to be the same number. 1 minus negative 1 wouldn't be 0. Negative 2 minus negative 3 wouldn't be 0. 3 minus 2 wouldn't be 0. And here we go, 4 minus 4, that would be 0. So here's our answer. Number 11, the roots of the equation. So we're looking at the roots for a quadratic, and these are all descriptions of the type of roots you can get. So this is a discriminant question. And we want to use the discriminant b squared minus 4ac. This alone can tell us what the roots will be like. So in this quadratic, I see a is 3, b is 2, c is negative 3. So my discriminant would be 2 squared minus 4 times 3 times negative 3. So 4 plus 36. My discriminant is 40. So let's see what 40 tells us. 40 is a positive number. So when the discriminant's positive or 0, our imaginary roots won't happen. Imaginary roots happen when the discriminant is negative. I'm going up from the bottom. Real, rational, and equal. Well, equal roots happen when my discriminant is exactly 0. And it's not 0, so it's not that. Number 2, real, irrational, and unequal. Real, rational, and equal is at the top. So the only difference here is, will my roots be rational or irrational? So the 40, the discriminant, is actually the value in the quadratic formula that's under the radical. We don't use a radical, but it would be. So if 40 were under a radical, would we end up with a rational value or an irrational value? And the answer is 2, because 40 is not a perfect square. Number 12. Given this real valued function, f of x is 1 over square root of x minus 4. So I want to be careful here. I see ahead they're looking for which number is in the domain. They're asking you which number would be okay for x. So let's see, can we do 1 over square root of 4 minus 4? Can we put 4 in there? Can we do 1 over square root of 3 minus 4? Can we do 1 over square root of negative 1 minus 4? Or would it be okay to do 1 over square root of 7 minus 4? So I think you can see this would give us a 0 in the denominator, no good. This gives us, number 2 gives us a negative in the denominator, no good. Same with number 3. So number 4 is our winner. In the denominator, you can't have 0, and under a radical, you need 0 or higher. So we needed higher than 0. Here's another domain question. So remember, they're asking us about the x values. Well, or they're giving us information about the x values, because I see range over here as well. The domain for g of x equals 5x minus 1 is negative 2 to 2. All right, so they're telling us for 5x minus 1, we are only going to use x's that range from negative 2 to 2. So if they're limiting us here, and they want to know about the range, we should do the work of putting all of these in. So I'm going to substitute each of these in and get a value for y. 5 times negative 2 minus 1. 5 times negative 1 minus 1. 5 times 0 minus 1. And this will be 4, putting that in. And 5 times 2 minus 1 will give me 9. Okay, so now that I've got my basic points for the line, it's asking me the smallest value in the range is. So the range is our y values, and the smallest value here is negative 11. Number 14, the multiplicative inverse of 4 plus I. A multiplicative inverse of anything like A is 1 over whatever it is. So the multiplicative inverse of 4 plus I is 1 over 4 plus I. And here we are again, needing Needing 1. If you said conjugate, you were right. We need another conjugate, this time for I. So we're going to 1 times 4 minus I on the top. And in the denominator, FOIL, we get 16. Drop out, minus I squared. There's that I squared again. 4 minus I over 16 minus negative 1. So we get a 17 in the denominator. 4 minus I over 17. There's our multiplicative inverse. Let's do one more in this part 1. And it says, what is the inverse of the function? Inverse of the function. Switch x and y. And then we typically solve for y. So let's see what we have. Instead of x equals 2y plus 3, I'm going to have y equals, oops, sorry, I said that wrong. We're going to put a y plus 2x plus 3 equals 0. So I'm switching a y in for x and an x in for y. So I've got my inverse now. Let's check the choices. Since these look a little familiar, it's not that, and it's not that. So let's solve for y, since that's what these two do. Y equals, subtract over 2x, subtract over 3, and here's our winner. Okay, so that's it for part 1. If I have time later, I'll do part 2. Study hard.